Okay, let's start the class. Okay. So welcome guys, welcome back to Chandu Biology Classes. So in this series what we are going to see is the gravitation topic. So as we have discussed the gravitation topic, like the basic things and the some topics of gravitation in last class, we will continue with that topic, right? So we'll start from the topic of Kepler's law today. So Kepler has been given 3 laws, okay? So based on the planetary motion. So the first law is law of orbit, we will say, okay, the law of orbit. So in this law of orbit, now what we are going to focus is all planets move around the sun in an elliptical orbit, we will say, okay, in an elliptical orbit with sun situated at one focus, like one focus of the ellipse, okay. Then here two things are there, okay. One is this 2b and this is 2a, where this 2a and 2b are called as semi-major, major axis and minor axis. So which is major axis? This 2a is called as major axis, okay, major axis, and this 2b is called as minor axis. So this is law of orbit, that is Kepler's first law. When we focus on the second law, right, okay, right. So when we go for the next one, that is Kepler's second law, that is law of areas. The line that joins any planet to the sun sweeps equal area in equal interval of time. So whether it can be a larger distance from the sun or smaller distance, but in equal interval of time period, it covers equal amount of area. For example, a sun is situated here, okay, now the planet is around at this point. So at t1, like t is equals to 0, this is at t1, no, it has been went to this point. Now if I calculate this area, for example, let me take this area is for example this is x, okay, x. Now at this point, now the planet is there, okay, at t is equals to 0, at t is equals to 1, no, t is equals to 1, the area covered is same x, same x. So it can be anything, like it can be from larger side or smaller side, but the area covered will be equal. That's why the delta A1 will be equals to delta A2. So this is Kepler's second law, that is law of areas, right. So in this, the important formula is, which we are going to say is delta A by T will be equals to constant, or else we can say delta A by T will be L by 2m, where L is the angular momentum. So angular momentum will be always constant when we talk about the law of areas. So this is the formula. So delta A by T will be equals to L by 2m, where m is the mass of the object, okay. So can we go for the next one? Okay. So the next one is Kepler's third law. So first law we have seen, second law, the third law, that is nothing but law of periods. Like law of periods is nothing but like time period, right? So the square of time period of a revolution of a planet is proportional to cube of semi-major axis. Semi-major in the sense, like we have talked about 2a as a major axis. Major, where semi-major in the sense half of the major, which is nothing but a. So t square directly proportional to a cube is the law of time periods, okay, where t is the time period of the planet and a is the length of semi-major axis of the ellipse, okay. So this is about 3 law of Kepler's, okay. So the next thing is given in a simpler tabular column. So gravitational potential energy, the first one, next one is force from potential energy, and the next one is near earth surface, what is the potential energy, like everything talks about the potential, okay, potential and potential energy. For multiple masses, what will be the potential energy? So potential energy formula is U is equals to minus Gmm by R, where capital M is the mass of earth or planet, and small m is the mass of the object which we consider in the planet, okay, mass of the object, okay. So next one, what is the relation between potential energy and force? So when we talked about the work energy and power, we have talked about conservative force and non-conservative force. So conservative force is nothing but it depends upon the only initial and final point, it doesn't depend on the path traveled, whereas non-conservative force depends on the path traveled. So same, there we have discussed the conservative force and potential, like potential energy relation is F is equals to minus du by dx or dr, whatever it is, like the distance, okay. Now the same formula only, F is equals to minus du by dr, which is nothing but F is minus Gmm by r square, okay, which I can say that by dr, by dr in the sense I can multiply the r value, so I can get the cancel of that one, right. Now near the earth surface, the formula is mgh, the potential energy formula, right, mgh. And for the multiple masses, I can keep on adding that. So for example, G m1 m2 by r12 plus G m2 m3 by r23, like minus of, okay. So this is how we will add the potential energy for every cases. So this is a basic concept of potential energy, like gravitational potential energy, force from potential energy near the earth surface for the multiple masses, okay. So you can take a note of this and we'll go for the next one. Done? Can we go for the next one? Okay. So here is the example, okay. So how we need to add that the potential energy, right. So V is equals to U is equals to minus Gmm1 mm by r, right. So suppose equilateral triangle has been given, okay, equilateral triangle, and the masses are kept at the vertices of the triangle. Now I need to add that, okay, I need to add that. So which means V12 plus V23 plus V13, like for example, this mass will be acting on M2 also, M3 also, and M2 will be acting on M1, M3, M3 will be acting on M1 and M2. So when I talk about M1, it's acting on 2 and 3, so 1 and 3 is there, fine. When I talk about 2, 1 and 3, so 1 already is there and 3, right. So this is how we will add the potential, okay, potential energy for given objects. So suppose let me take a square, okay. Now if I talk about a square, 4 vertices are there, so 4 edges are there, 1, 2, 3 and 4, right now, okay. Now if I talk about the potential energy, how we can write u total will be equals to u12. Let me add 1 2 2 3 3 4 and 4 1 first, plus u23 plus u34 plus u41. Now when I talk about 1 acting on 2 and 4 completed 2 and 4, but 3 is left out, I can add that no u13. When I talk about 2 acting on 1 4 and 3, when I see here 1 is there, 3 is there, 4 is not there with respect to 2, so plus u24. Now if I talk about 3 acting on 2 1 and 4, 2 is there, 1 is there and 4 is there, fine. When I talk about 4 acting on this remaining 3 1 2 3, so when I talk about 4, 3 is there, 1 is there, 2 is there, so this is the thing. Now if I want to write, it is minus of G m1 m2 by r12 plus G m2 m3 by r23 plus G m3 m4 by r34 plus G m4 m1 by r41 plus G m1 m3 by r13 plus G m2 m4 by r24. That's it. So this is how we will write the potential energy of the given object, right? Okay, so the next one, gravitational potential. So potential energy we have seen. Now we need to check whether the energy is in that place, like a potential means whether that potential energy is capable in that area. So it is defined as the gravitational potential energy per unit mass, So how we can check whether that energy is there? By keeping a mass there, right? I am keeping an experience, I mean a particular mass, I can experience a force there. Suppose if I am swinging my hand like this, if a person is standing here only, he can able to feel the force, right? If he is away from the hand, he can't able to feel the force, right? The same thing, if this is my boundary, if I keep the mass over here, I can't feel the energy, but if I take the mass any of the point inside the system, I can feel the potential, right? Now that is the thing. So U is equals to minus gmm by r divided by the point mass m, right? So the final formula will be U will be equals to minus gm by r. So this is potential, and potential energy formula is V is equals to minus G capital M small m by r. This is potential energy formula, whereas potential formula is minus gmm by r, minus gm by r, right? Done? Okay, can we go for the next one? Okay, so the next one is escape speed or escape velocity. Escape velocity. So escape velocity is nothing but it is the minimum speed required by a body to escape from the surface of the earth. Suppose I am throwing an object, so it will go to some height and it will come back because there is an opposing force is there, like that gravitational force is there. It will try to pull the object towards the center. But if I give some amount of velocity to oppose that force, what will happen? the object will go out of the earth's surface. The same thing, consider a small body of a mass m thrown up, it will come back after some time. Yes. So now throw it again with a larger speed, that it goes to infinity. Okay. So this speed is called as escape speed or escape velocity. Okay. So assuming that out of the earth surface the speed is 0, like the a value will be 0, this is b, like at the earth surface. So now whatever thing we are calculating, we will calculate in terms of energy conservation. So energy conservation means when I am in the earth surface, the potential energy and the kinetic energy will be same at the other point also, right. So total energy at B will be nothing but kinetic energy plus potential energy. What is kinetic energy? Of mv square. What about potential energy? It is minus g m by r. No, the same thing. G is constant, mass of earth and object mass divided by radius of earth, okay, and velocity ve they have given, no, it is nothing but escape speed or escape velocity, okay. Now at the point A, B will be equals to 0 and this r will be equals to infinity, which is nothing but 1 by 2 m 0 square minus gmm by infinity, right, infinity. So this total term will become 0. When I equate, total energy at B will be equals to total energy at A, right. So of mv square minus gmm by r, what is the final result we will get is VE will be equals to under root of 2g r. So how we got 2g means, like this is the equation we got, right. So we have taken half mv square one side and gmm by r other side. So VE square will be equals to 2gm by r, where g is nothing but gm by r square. This one we have discussed in the previous class, where F is equals to mass into acceleration in terms of gravity, and one more thing, F is equals to gmm by r square. So this is gravitational force and this is the one force. When I equate these two things, no, mg will be equals to gmm by r square, where m and m will get cancelled, g will be equals to gm by r square. So that's the thing they have written here, right. So we know the value of g and know the value of r also. So 9.8 meter per second square and value of r is nothing but 6400 into 10 power 3, right. So when I calculate, we get a velocity that is 11.2 kilometer per second. So if I throw an object with 11.2 kilometer per second, the object will escape from the surface of the earth. This is the escape velocity of the earth, right. You can take a note of this. Okay, we will go for the next one. So next one is orbital speed. Orbital speed is nothing but now the thing is, we are sending a satellite out of the earth's surface. Now how that satellite is revolving around the earth, right, the same concept only, right. An horizontal velocity required for an object to revolve around a planet in a circular orbit. Okay, this is orbital speed we will say, okay. So centripetal force, what is the meaning of centripetal force? A force which is towards the center of the circular path, right. When I talk about a circular path, a force will be there which is towards the center, that is centripetal force. That force formula is F is equals to mv square by r. So the same thing we are going to apply in the orbital velocity also. So centripetal force on the satellite, which is nothing but v0 we have taken. So ve is mentioned for escape velocity, v0 square by like radius of the earth, and we have taken some height h, right. So mv square by r plus h, And another thing, gravitational force attraction of the planet of the satellite, which is, we know that F is equals to G m by r square. So in place of r square we are substituting r plus hd whole square. Now this is also force and this is also force. We will equate these two forces. Okay. Now what we will get? mb square by r plus h is equals to gmm by r plus hd whole square. So from this we will take v square. So v square will be equals to gm by r plus h, where radius of the earth will be greater than the height which we have considered. So we will neglect that height. So root over gm by r, right? The same thing, gm by r square is g, gm by r square is g. So I can say that into r e by r e, right? It's everything in under root. So this total term is g, so root over g into r e, right? So the value is 7.92 kilometer per second is the orbital velocity. So if I take the object, okay, this object speed will be, or the satellite speed will be 7.92 kilometer per second, right? So this is the orbital speed. Now some more topics we will see, like that is time period of the satellite. How to calculate the time period? We know that speed or velocity is equals to displacement by time, where time will be equals to displacement by velocity. So what is the displacement of the circular path? It is 2 pi r, like circumference of the circle is 2 pi r. So 2 pi into r plus h, we are calculating for the orbit, no? So radius of earth plus the height divided by the velocity of the orbit. So we know the velocity of the orbit, that one we have calculated in the previous slide. So if we substitute the value, v naught is equals to root over gm by r plus h in here, no, we will get this t square is equals to k into r plus h the whole cube. Somewhere we have seen the formula, right? Yes, it is Kepler's third law. T square is directly proportional to a cube. The same thing, t square is directly proportional to r plus h the whole cube. Okay. So where k is the constant, which is nothing but 4 pi square by gm. So g is gravitational constant and m is mass of the earth. Okay. So this is time period of the satellite. Time period of the satellite. So next one, energy of the satellite. So how energy of the satellite, in the sense, what are the energy we are talking? Kinetic energy, potential energy. Apart from these two things, total energy, which is nothing but combination of kinetic plus potential. So kinetic energy formula is half mv square. So v, velocity of orbit, we are calculating, right? So it is gmm by 2 times of r plus h, whereas potential energy is minus gmm by r plus h, right? When I add the both the things, I will get the total energy, which is minus gmm by 2 times of r plus h. So when here they can ask a question, so what is the ratio of total energy, potential energy and kinetic energy of the satellite, they will ask. Okay, they can ask. Okay, so here is the relation. So this is kinetic energy, this is potential energy and this is total energy. Total energy. So ratio is 1:2 minus 2:1. 1:2 minus 2:1. Right. So I hope you have got some idea about the gravitation, right? So we'll see some previous year IIT JAM questions. Okay, IIT JAM questions. Excuse me. Okay, so the first question what we are going to see is, a satellite takes 24 hours to orbit the earth. Okay, it is replaced for a newer one that is carrying more modern equipment, making it's 2 times lighter. Okay, fine. The new satellite has an orbital time of 24 hours. What is the ratio of the radius of the new satellite orbit to the older one? What is the ratio of radius they are asking? Radius, no? So, what will be the answer for this given question? It is a IIT JAM BT 2006 question. Okay, options are given 1:2, 1:1, 1:√2 and 4th one is 2:1. So, given that satellite takes 24 hours to orbit the earth, fine, that is the first point. It is replaced for a newer one that is carrying more modern equipment, making 2 times lighter. So, the weight has been reduced, I mean the mass has been reduced. The new satellite has an orbit time is 24 hours, same. What is the ratio of the radius of new satellite? Okay, so since they have not mentioned about the radius, no, it has been changed, right? Only the mass has been changed, it has been replaced, that's it. So, when I talk about the time period and the radius, no, so T square directly proportional to A cube. Is there anything mass is there? So, I can say it is independent of mass. So, answer is 1:1, 1:1, right? Answer will be 1:1, that is the answer. Yes. So, when I talk about this, apply conservation of momentum, velocity changes, but when I am applying T square directly proportional to A cube, time period independent of mass, so the radius will remain same. So, the next question, the center of, yes, it is IIT JAM BT 2008 question. So, the center of two planets P and Q are at the distance L. Okay, so two planets are there, P, Q, the distance is L. Apart, and the ratio of their masses is 1:4. 1:4 they have given, fine. What is the distance between the center of the lighter planet P and the point on line PQ, which is net gravitational force is 0. So, what they are saying, somewhere at this point, any of the point, okay, I mean in this line, any of the point, I can experience a zero gravitational force. So, what is that point they are asking? It is L/4, L/3, L/2 or 3L/4. Okay. So, we will solve this question. So, now we know that, yes, here itself we take, suppose if I take this point, if this is x, so remaining will be L minus x, right, same. So, GMP by x square, what is the formula? GM by r square, right, no? So, where I can cancel the mass and mass there. So, only remaining mass will be mass of M and mass of Q, okay. So, mass of P and mass of Q. So, Gm by x square will be equals to Gm by L minus x the whole square. Again G and G I can cancel it out, right. So, what is the mass they have given? It is 1, like M, mass of P is 1, mass of Q is 4. So, we will substitute the value, 1 by x square will be equals to 4 by L minus x the whole square. So, if I expand this one, what happens? 1 by x square will be equals to 4 by, so A minus B the whole square, what is this? L square plus x square minus 2lx. So, cross multiply it. So, L square plus x square minus 2lx will be equals to 4x square. Either I can do like this expansion, or else 2 and 2 will get cancelled off easily, direct, right? Or I can say this one, 1 by x the whole square will be equals to 2 by L minus x the whole square. So, 2 will get cancelled. So, 1 by x will be equals to 2 by L minus x. So, cross multiply it, L minus x will be equals to 2x. So, L will be equals to, say x will be equals to L by 3. So, what is the correct option here? Option 2 is the answer for this question. Option 2 is the answer. Yes. So, let me go for the next question. We will see who is going to give answer. So, two satellites of mass m and 2m are orbiting around the earth in a circular orbit of a radius, okay, around the earth in a circular orbit in r and 2r. So ratio of their speed they are asking, ratio of their speed. So this question is from IIT JAM BT 2009. So what is the answer? 2√2:1, √2:1, 1:4 and 2:1. So give answer for this question, we will see. Done? Okay, can we go for the answer part? Okay, so they are asking two satellites, no, two satellites in the sense velocity of orbit, right, will be equals to root over gm by r is the formula, right, root over gm by r. Now I need to find the ratios. So mass is given and radius is given, fine, right, mass is given and radius is given. How we can find the things? So two satellites of masses m and 2m, m and 2m. Okay, you guys will try this as a homework, fine. So complete this question, we'll see who is going to give answer, right. You can comment the answers in the comment boxes who are watching. Okay, so the next question we'll see, yeah, which one of the following statement is not correct? So this question is from IIT JAM BT 2010. Okay, a mass m is enclosed in a spherical shell. The gravitational force on this mass due to another point mass m lying outside the shell is 0. That's the first statement. Second statement, when an object of a mass m is in motion under a gravitational force, both angular momentum and total mechanical energy are conserved. Yes, it is conserved, right. The acceleration due to gravity decreases with increasing altitude. Yes, obviously, right. The acceleration due to gravity is depend on the mass of the earth. Yes, it's not same for all planets, right? Yes. So the first option is the not correct, right. So in increase is incorrect because for finite masses separated by a distance, the gravitational force will be F is equals to gmm by r square, right. A shell exerts 0 inside, but external mass due to external force will be F will be equals to gmm by r square, right. So this is the answer for the fourth question. So the final question we will see. So this is IIT JAM BT 2011 question. A satellite has an elliptical orbit around Earth. Its maximum distance from the Earth is d1 and the minimum distance is d2. The corresponding tangential velocities are v1 and v2 respectively. The ratio of velocity at this distance is. So I need to find what is the ratio of these velocities, right. So to calculate this, angular momentum conservation we are using, which is momentum is nothing but mass into velocity. Angular momentum is nothing but mvr, right. So m1 v1 r1 will be equals to m2 v2 r2, right. Why we have taken m1 and m2 as same? Because we are taking the same object, right, same object. That's why m1 and m1 we have taken. So both will get cancelled off, right, both will get cancelled off. So v1 r1 will be equals to v2 r2. So r1 is nothing but d1, r2 is nothing but d2. So V1 by V2 will be equals to D2 by D1. So the option is 3. This is the correct answer. Okay. So I hope you got some idea about the gravitation and you can do some questions on this, right? So with this we'll end this session of the gravitation and we'll meet in the next PCM series of IIT JAM, okay, in next session, right? Thank you guys. We'll meet in the next class.